Okay, welcome back. Let us continue on our journey to becoming good at SolidWorks. Today I want to talk about how to create a part and then make a drawing for this part. I looked a bit at different tutorials and what there is out there, and I think most of it is aimed at, I have no idea who it's aimed at. But we're gonna go through a bunch of best practices, how to make drawings, what drawings mean, and so on. So as you can see, I already picked the front plane. I chose a circle. By the way, if at any point I'm doing things way too fast, then tell me down below and I will go slower over them. Now, smart dimension, your best friend. Let's say this is a 20 millimeter diameter shaft. Now we want to extrude. Let's say this is 100 millimeters long and it's on the mid plane because that usually helps. All right, so we have a part and we're gonna define some material. Let's say this is a whatever, alloy steel. Cool. So let's save our part. Let's call it shaft. It's a big strong shaft. Now we have this part. Cool. Ooh. So what? A part on its own usually it doesn't really help you because it cannot get manufactured. Like I'm not gonna say there's no way to manufacture I'm not gonna say there's no way to manufacture a part without a drawing, but usually it's done through drawings. So you go to new, like you can make a new and then drawing and then pick the thing, but I just go to make drawing from part or assembly. You choose whatever template you have, then you come here. This would be an A4 because it's a super tiny part. Then you can go to 3 standard views of shaft, you tell it okay, and you have these parts. Okay, other than that, let's say you don't like these views. You go to model view, you decide which part you want to show, and you place it somewhere, then you can change it. I usually, like, I don't predefine everything because I don't really know beforehand how it's all gonna go, so I change it as I go. The isometric view is usually going to be at the bottom right. Some companies do it at the bottom left, whatever. Ask your boss, he will tell you. And there's a thing called first angle and second angle. This is super important. And you can change it here. Usually in Europe we work with first angle, and in America you work with third angle. Now, so let's say here I want to place another one. I click it, then here I can go to standard views. I can tell it, oh, I want it like this, like that, like here, like there. Usually I will do this. For this part, it doesn't really matter, but other parts have, like, when you go to projected view and you want to give it a 90-degree turn, and here, like, it's a circular part, right? So it's not gonna matter. But later on, we're gonna do rectangular parts or amorphous parts, and you're gonna see. So this looks all right, but it's a bit too small. So I'm gonna go here, I'm gonna go properties, and I'm gonna tell it 1 to 1. All right, that looks good. So I would define the diameter here, 20 millimeters. Make sure your units are set up correctly. I am in MMGS. You will be probably something else. Or not, I hope not. Center lines, I don't know. The first position I ever worked at, the guy who was my supervisor was horrible about this. Like, as if center lines are the most important thing. Center lines have a meaning, they have significance. Specifically for this part, I would say when you look at this thing, let's say this is not here, you might be tempted to show this and be like, what? Of course it is circular. I just drew it over here. Look, it's circular. Yeah, but from a 2D perspective, this is a rectangle. This could be a box. This could be something like this. Let me just sketch it real quick. Yeah. Just show you real quick. So, that should have been vertical. Yes, vertical. Good. Extrude. What was it? 100. Mid plane. Yes. Okay. Now, because you saw me draw it, you know which is which. But from the side, they are exactly identical. I mean, of course. You might see that this is slightly, but no, in 2D, this doesn't work. So you have to specify. This is something that you learn either the hard way or someone teaches you slowly how to do it. So yeah, you add this because you want to show that it's circular. You can add the length. If you have other things, you can add them too. Usually you will have surface finish or not, depending on the usage. Let's say it's RZ25. You can have more information here about like how to, what you want, the processes, the treatment. You can say it's anodized, you can say it's whatever. This is for later on. And so you have, now you have to check, is this, will someone be able to manufacture this? Like, okay, you take a 20 millimeter cylinder, you cut 100 millimeters, and basically that's it. That's the whole part. And it's important to practice here because later on when you have super complex parts, this gets very hairy. And I think I can show a few parts later on in some videos, like parts with 3-sheet drawings on A0 pages, and they're like filled to the brim with information, and you have to find your way around it. Goddamn bikes, man. So basically now another technical person who is not you can look at this part and say, oh, okay, this is a shaft, it's 20 millimeter in diameter and it's 100 millimeters in length. I don't think we should get into tolerances right now, but let's have a super quick like listing of what you can do. So you pick a dimension. This is a smart dimension, like what you do on sketches. You go here to tolerances and precision, and you can choose the type of tolerance you want. So let's say symmetric. This is very often used. And then you tell it it needs to be 100 plus minus 1 millimeter. Let's say we don't care. Let's say we don't care. The machine is the machine can contain a difference of up to 1 millimeter, because as you know, or as you should know, there is no absolute theoretical dimension that can be translated into the real world. There will always be differences, and here down below you should have the thing that says it is the tolerance class that you use. Like the most often used is the ISO, I don't remember, ISO classes. Let's see. I'm sorry. This is taking a long time. I think it's a 2768. Anyway, so you can see here, this, I think, you can see. So it's either the middle or the low tolerance or the high tolerance. Like you can see, this allows more and this allows less for the distance or the size of the dimension. So we had 100 for the length. That means in the middle it will be plus minus 0.4. So by doing plus minus 1, we're actually giving it more clearance, or like we're giving it more freedom than the rough tolerance class. And then this one for 20, you are between 10 and 30, so it will be anywhere between 0.05 and 0.2 if you just leave it like that. And here we gave more leeway for whoever wants to manufacture this than they would if there was no information and just this at the bottom of this page. And that's yeah, that's a basic way to draw a part. I personally didn't get this much information when I was, when I was studying to become a mechanical engineer, when I was fresh out of university. So I hope someone finds this useful or helpful or anything. Yes, let's save it for shaft, and maybe we can use this later. Another thing, a lot of people will tell you have to know how to set up your own header and information and blah blah blah. Unless you're a freelancer who does their own, like you sell your own designs or something like that, this will usually be filled out by your company, who, they have a person who does this, and you are most likely to not be that person straight, like right off the bat. But basically, if you must know, it takes information from here. You can tell it like weight, then you tell it text, and then you can take it from mass, and then it should be, yeah, there you go, weight. So if you want it to look nice, you can do it for sure. And you can also go here and give it a, let's say, description, text, paste, and where's that shit? Shaft. Yeah, there's a way to, I think it needs to be a command. There's a way to make this derive from something else, but depends on the company. Like usually you have to define this on your own, and it's really annoying. It's better when it does it automatically, and the guy who is in charge of that will do that, hopefully, for you. Yeah, I think that I will cut it here, and we will continue the next time. Hit like, subscribe, comment, send it to people or your friends, whoever is studying SolidWorks or going to start mechanical engineering or whatever, and it will help me greatly, and it is for free for you. I will see you some other time. Take care.